speaker. So our next speaker coming up here is Mike Milner. Hey, Mike, how are you?
Good, thanks. How's it going?
Very good. So you're Director of Application Security Technology at Trend Micro.
That's right. I manage product strategy for our Cloud One application security product.
Okay, terrific. Well, so Mike's going to talk to us about observability for security and audit. And I got a pretty good idea what that means, but I'm going to let you just take it away and explain it to them right after I remind everybody. Put your questions into the Q&A tab to the right of the screen here. And when we get to the end of Mike's talk, we'll be able to address those questions for you as well. So without further ado, here you go, Mike. I'm going to turn it over to you.
Great. Thank you very much. So as I said, my name's Mike. I'm an engineer and a developer, and I've been working in the security space for just under 20 years now. So first, I want to start this talk by saying hello from Nova Scotia, Canada. I want to send out my hope that everyone's staying safe, and a big thank you to all of you for staying home. You can see love from my daughter up here as well. And of course, big thank you to the event organizers. Thank you so much for making all of this possible, and thank you to everyone for all the help you're giving to support the COVID-19 efforts. So I spend a lot of my time thinking about application security. As I said, I manage product strategy for part of Cloud One. We focus a lot on protecting modern applications in the cloud with serverless technologies. AppSec is not a new field. The first public disclosure of, or discussion, I should say, of SQL injection happened back in 1998. But like anything, I'm always looking at other industries, other parts of our own industry for inspiration on how we can make AppSec better. Observability has become a bit of a catch-all term for, in my opinion, a lot of great things coming out of or tied with the DevOps culture, the DevOps movement. This idea that if you can't measure it, you can't improve it. So I want to take a look at some of these DevOps changes and technology that's really enabled DevOps for some inspiration. Depending on your industry and perhaps how long you've been in the industry, you might recognize this. If you've ever used VPC networking in something like Amazon, this is what it used to look like before the cloud. I'm starting with this picture because it illustrates, in my mind, one of the big shifts and enablers of DevOps, this concept of cloud APIs defining infrastructure. All of this complexity can be reduced to some API calls that are completely reproducible. And going even further, you can manage all of the definition of this in files that can be version controlled, and changes can be peer reviewed. This idea of infrastructure as code. So this change, this technology that's really enabled DevOps is also really great from a security perspective. By having everything controlled by an API and version controlled in files, it makes it very easy to log and track all the changes and see why changes were made, and go back in time using something like AWS CloudTrail to understand exactly what was changed when and by whom. I mean, I look at this picture and you can kind of see just there in the middle, what's that little yellow wire that snakes over to the blue side? Is that supposed to be there? How long has it been there? Who put it there? That's hard to answer when it's physical infrastructure, but much easier to answer when you can leverage these cloud technologies to really dig in and understand. So how does this apply to application security? In my kind of hand-wavy definitions, I kind of look at DevOps as really continuously ensuring your app works the way that you intend it to work. And AppSec is really continuously ensuring that nobody can make your app work in a way that you didn't intend it to work. So you can see they're very similar. So can we leverage some of the same technologies, the same mindset, the same tooling to get some of the same benefits that we're seeing in DevOps, which is completely transforming the industry, and kind of get some of these improvements in AppSec as well? I'm sure you've heard the name DevSecOps. It's really this concept of using some of the same technologies and working closer together to get some better outcomes on all sides. I find these definitions highlight some of the differences in how we look at things. If you've got a bug in your software and a user's using it, something's not going to work the way they want it to, and they're going to complain. They're going to open a bug. So you usually hear about bugs fairly quickly, maybe too quickly for some. And that is kind of a short time window from bug to when you're aware of the bug and when you can try to fix the bug. Another big difference between kind of that idea of developing an AppSec bug versus vulnerability is the intent behind it. If a user stumbles across a bug, they want it fixed because they want to use the product successfully. If an attacker finds a vulnerability, they really don't want you to know about it. They don't want you to fix it because they want time to exploit it, to cause harm, to use your resources. So the disclosure cycle for vulnerabilities is usually much longer than for bugs. A vulnerability might exist in your system for a long time. It might take you a long time to find it. There's countless vulnerabilities that you might never find, and hopefully attackers don't either. But that time scale difference really changes how we investigate and look at them. So let's take a look at some of the DevOps tooling that lets us move fast and fix bugs and see where it can help us for AppSec. So I've just put a handful of examples up here that have been very helpful for solving bugs, solving production issues, slowdowns, that type of thing. System monitoring, looking at how your systems are performing, CPU, memory, those kind of traditional metrics. Network monitoring for really deep problems. If something's really not working, being able to go right down to the network level, look at packets, look at IP addresses, trace exactly what's happening. Hugely beneficial if you've got issues affecting that low level. More on the application side, you've got just good old logs. Your application is logging data. If there's a bug, you can go in and look at those logs, see if there's anything there that will give you a clue. If not, maybe you adjust the log levels, put it down to debug. Look at those debug log level data, much more information, hopefully help you again zero in on the bug, fix it, deploy that code, and then usually you're going to bump the log level back up to the default. APM, application performance monitoring and distributed tracing. This idea of being able to look at a single request coming in and track all of the interactions as it hits various parts of your infrastructure can also be hugely valuable from a security investigation point of view. If somebody can send a bad request, tracing where that hits, if it's hitting other microservices, generating SQL queries, API queries, all these things that are very useful for understanding how a system works. For bug finding is also very useful for security investigation. And then the last one, version tracking, really just all of that whole build pipeline. Understanding what code is running where, when it's changed, why it's changed, how it affects. That's hugely important for DevOps. But if there's a bug in that code that ends up being a vulnerability, this is also hugely valuable for security. So all of this data, like I said, is useful for both. But because of that time scale difference, there's a bit of an issue with that. For bugs, you're usually looking at very short term. You want to understand what's wrong with your product right now, what's wrong with the system now, or at least in the very short history. Because these bugs, you generally find them quickly, you can fix them quickly, you don't need to retain this data for that long. With a security perspective, that shifts a bit. like we talked about on the last slide, and the security side of things, you might not even know there's a vulnerability for a long time. And when you do find it, if you find it yourself, you want to be able to look back and understand how that's been impacting your infrastructure. Some great examples, I'm sure you know of the shell shock vulnerability. This is a vulnerability that was intrinsic in a lot of applications for a long time. But once it was disclosed, people were able to quickly fix their infrastructure, hopefully quickly. But what you'd really like to do at that point is look back in history and say, were we being exploited by this? Did we ever see this on our infrastructure? That's an example where having a long history of some of this data would be hugely valuable. The struts2 vulnerability or vulnerabilities, when those were disclosed, being able to look at your infrastructure today, understand when your fixes are going out, but then also look back in history to understand, were we seeing this? Was this hitting us? Hugely valuable. A lot of cases, you might find out about a breach after the fact. Maybe information is disclosed, somebody finds it on the dark web, and now you have to try to figure out where that data came from. Being able to look back in history, find out what requests were coming in, what tables they were hitting, all of that can be hugely valuable. But it means storing data for a lot longer than these tools are traditionally designed to do. So what I wanted to do is kind of look at that concept, look at these tools, look at those types of security investigations, and try to kind of come up with what would be the perfect world if we could kind of build something ourselves. So if we were able to keep this data for longer, what would we want to keep? So of course, everything, right? Now that's not always possible, but here's some examples that I thought of just off the top of my head that could be very beneficial for security investigation. The first, packets coming in. You're probably familiar with the Heartbleed vulnerability. This was a bug in the OpenSSL library, where in the TLS session establishment, there was actually a vulnerability that could be used to extract process memory. So let's keep all of the raw packets coming in from the internet. Let's store those so that if we ever find out about a new Heartbleed, we can go back through those raw packets and find out whether anybody was exploiting our systems using that technique. After TLS is terminated, let's keep the raw HTTP packets. That gives us every byte that's coming in off the network, our HTTP headers, the request body, payloads, JSON, XML, whatever it is, let's just keep it all. In there is HTTP headers as well. Those are a big factor in a lot of attacks, so let's keep those. Kind of to the distributed tracing and APM concept, let's keep these request IDs of the requests coming in, that unique trace header that we use to track all of those requests through the system. Let's keep those as well. Assuming a lot of these requests are authenticated requests, let's keep the session IDs so that we can then trace those back into our authentication system so that for every request, we know who did it, what user account, when they authenticated, how they authenticated. And then just this concept of runtime IDs. So let's keep track of what parts of our infrastructure are involved in serving this request. What version of code was running at that moment, so that if we do find a bug in historical software, we can look at all the requests that hit a particular version of our code. And while we're at it, all that logging, why not keep all the logs that were generated as part of every request? And if we're able to, if our infrastructure allows it, can we just keep the debug log records for all of these as well? If our application's making queries, can we keep the SQL queries associated with each request? So that every request coming in, if it made selects or modified data, can we keep all that data? Now, two big problems that jump out immediately is it's a lot of data. If you're storing this for every request and you want to keep it for a long time, that's going to be expensive. A lot of that mindset comes back to those original tools that are designed for DevOps. Because they're designed to look at near-term data, they're optimized for fast recall of that very recent data. And often because of that, it's very expensive to keep data for a long time because they're designed to keep that data in hot indexes, fastly queryable. So you're either paying a huge amount to store that data in those fast indexes, or maybe you're just slowing down everything by bogging it down with all this old data. So storing this volume of data might be very expensive. There's also definitely issues with storing of personal information. Inside all of this, these raw packets, these details of a request, is potentially a lot of personal information. So depending on your industry, you may or may not be able to store this at the raw level. You might have to strip out some personal data or sensitive data. Obviously, you need to comply with that. But for this example, I'm just looking at the scenario of what if we could keep it all. So what I did is I went through and I picked a sample API in this case from real running infrastructure. And I just tried to attach some numbers onto this data. How big is it? Looking at those raw packets that generate a request, the raw packets of a request itself, the headers, all those queries, logs. And for this particular API, all of this data adds up to around 3 kilobytes per request. Now, clearly, this is going to be different if this is maybe a web app that's serving giant HTML pages or big CSS files or JavaScript, or if it's serving images or something like that. But this is just one example with an API. So all of that raw data works out to around 3 kilobytes per request, and not compressed. So that'll give us a data point. Again, it might be very different for you, for your apps, but it gives us something to talk about. And if we look at that volume of data, and let's try to categorize it in terms of overall storage. So I picked some sample kind of numbers of what if we had 1 million requests per day. We saw from the last slide that we'd be looking at around 3 kilobytes per request. So that works out to roughly 3 gigabytes per day of new data generated. Now, if your system is different, if you have 10 million instead of 1 million, you're going to have 10 times the data, 30 gigabytes instead of 3. So obviously it will change depending on your application. But again, this is a point to talk about. So 3 gigabytes per day. What if we just wanted to store that, long-term storage? So I'm very familiar with AWS, so I went to the AWS price list for S3. This data is not going to be looked at all the time. It's mainly for investigating. So I kind of went with the infrequent access, the kind of archival storage levels with S3. The first is S3 standard infrequent access. It's still millisecond response time, but it's designed for less frequent access. And that works out to be around 1.25 cents per gigabyte per month. S3 Glacier, a little bit longer retrieval time or slower retrieval time, still well within the window of what we would need for this type of application. And for that, it's 0.4 cents per gigabyte per month. And then for the really slow stuff, they've got S3 Glacier Deep Archive, 12-hour access time, but as you can see, even cheaper again. So here's some technology enabled by the cloud, just like that stuff we talked about with APIs and CloudTrail. Can we leverage some of this cloud technology and cloud pricing to perhaps make some of this long-term retrieval for security possible, where maybe it wouldn't have been possible before? So let's do the math. If we're looking at, let's say, 1 year retention, so we want to keep all this stuff for a full year, that 3 kilobytes per request multiplied out to 1 million requests works out to be just over 1 terabyte of data being retained at any given time. If we multiply out the prices, S3 infrequent access, it works out, it's only about $13, $13.75 per month. You can see S3 Glacier is a bit cheaper, and Deep Archive even cheaper again, almost just $1 a month. In terms of storage, this is very, very cheap for storage. So lets us store all this data. But a key part in any system like this, we want to be able to investigate. We want to be able to pull out the data that we need. So again, leveraging some cloud technology, I looked at this feature of AWS S3 Select and S3 Glacier Select. What this does is it, in a sense, lets AWS do the searching and filtering on their side, and you just retrieve the actual data that matches your filter. As long as you're storing data in CSV files, JSON, or Parquet, a format that's very popular for big data searches. Excuse me. If you're storing your data in one of those formats, you can actually issue a select query to S3. It's going to look through your data and take that query that you specify, which looks very much like an SQL query, and it's going to find all the matching rows and return only those rows. And with JSON and Parquet, you can actually have nested structures, more advanced structures. So you can store all of this data. And when it returns it, you can return it as CSV or JSON. That gives you just the matching rows. So that's really the next step, or the final step, in being able to query this bulk data. So for my hypothetical example that you saw there, it's, let's see, every request stored, 1 million requests a day. We're storing that for a year, and it's going to cost us maybe $14 a month in terms of raw costs. And then the query costs, which we can control as we make the queries, depending on how frequently we want, or sorry, I guess how quickly we want the results. So with a few bits of cloud technology, we're able to really enable some new AppSec capability in much the same way that cloud technology has enabled a lot of new DevOps technology. And I hope it also serves to show that maybe you're a developer and you don't know a lot about AppSec, but there's a good chance that you know a lot about those DevOps tools that I talked about. So if you know a lot about those tools, you actually already know a lot about how AppSec investigations work. So being able to leverage them for both purposes has a lot of advantage. So next steps for me for this topic, there's a few other aspects that I wanted to look at as well. So OpenTelemetry is a nice open project that's designed mainly around APM style technology. This concept of, if you're going to instrument an application and do deep instrumentation, get those SQL queries, the file access, can you do it as well for AppSec? I mean, in the products that we build, we focus a lot on stopping the bad requests, which of course you want to do, but you don't always know they're bad right at that moment. So having technology like this to be able to look at all those requests that you thought were good and find the bad ones has a huge value. Another aspect, things that can be logged, application lifecycle, containers and pods starting up, stopping, tracking all the versions of code. Lower level tracing, eBPF, kernel tracing, OS tracing, looking at files being accessed, processes being started, hosts, network connections being established. All that stuff, again, hugely, hugely valuable. So I hope some of this has given you a bit of inspiration. I hope it's given you a bit of a thought on maybe if you're looking at things from the DevOps perspective, how that can be beneficial for security. If you're looking at the security perspective, maybe you should be tapping into some of these DevOps tools that developers are already using. These aren't two separate disciplines. They're definitely tightly coupled. So thank you very much for taking the time with me today. And that's all I have for you.
Awesome.
Any questions?
Well, thank you, Mike, so much, first of all, for a great presentation. And a reminder again, folks, if you have questions for Mike, you can put them into the Q&A widget to the right of the stream. Looking right now, I don't see questions out there at the moment. just somebody in Slack saying that you're a fantastic presenter. I have to agree.
Well, thank you very much.
Are you going to be around in Slack for a little while, Mike?
Yes, I'll be in Slack. You can find me, Mike Milner. You can also reach me at Twitter. I just noticed I don't actually have it up on my last slide, but at Secret Mike, you can find it in the venue. Feel free to reach out with questions, suggestions, inspiration. I love hearing about it all.
Someone else thinks you have a great radio voice, and you can't argue with that. So I'd have to agree. Awesome. Well, thank you so much, Mike. We'll let you go then. And folks, we're going to take a real